So remember, we were going to use Euler's method to find this value. And so our sort of first value, t0, y0, is here, 1, 2. My first t value, my first y value. And so if I wanted to find this iterative method here, f prime of t I minus 1, and I wrote this as t, but actually the f prime is a function of t and I, right? Especially in this case, delta t plus f, so here's the derivative, and this is the original. So here's my formula. And I have my initial value, so I want to find my next value. And we're going to choose a time step, so I'm going to just make delta t equal 1. And this is somewhat arbitrary, but to get a good value, you want a smallest possible delta t. So what do we have here? Let's plug it in. y1, we want f prime of t0, y0. Delta t is 1, but I'll just go ahead and I want to write this in generically. Now, so let's find this value. I have this value, I have this value. This is just the y. So actually, I should have just written this as y I minus 1. So this is y0. The derivative is a function of both, but not the original. Okay, so let's plug it in. Let's plug in the derivative. So y prime of my initial value is, here's my derivative, so it's just 1/2 t over y. So let's plug everything in. So y1 equals the derivative times my delta t, which I've told you is 1, plus my initial y value. So 1/2 plus 2 is 5/2. And so then I can repeat this process. Notice that I need my derivative. So let's go ahead and, let me label what is my y1, t1 here. So what is our new time? Our last time was time 1, but I went up by a step of 1. So what's the new time? 2. I'm going to write that down. T0, it's just the change in time here. So that's T0 was 1, my delta T is 1, and Y1 we found up here. Okay, so let's sort of, I want to do several of these. So let's kind of make this like a step-by-step thing. I will start again on the next